So I'm here today with Bryan from LayerZero, and we're going to talk all about LayerZero V2. Yeah, looking forward to the conversation, Bryan. Let's jump straight in. Let us know about LayerZero V2 and what you shipped recently.
Yeah, I mean, LayerZero V2 was largely, most of what you can do in V2, you can do in V1. Everything was just made more implicit within the protocol. There are two things that were like very important upgrades. One was this decoupling of security and execution, which basically makes it so the entire system now moves to permissionless execution. I think what we realized is in a Uniswap style structure where the authority, basically in their case, the DAO lives on Ethereum. They want to be able to make governance changes on Ethereum and push a result out. So they just want to say, turn on the fee switch on some destination chain. What they don't want is to have a multi-sig or any sort of authority on that destination chain. So what it meant is that the relayer itself in the V1 model becomes some sort of permanent liveness failure. In the case of the relayer going down, they don't have the ability on destination chain to switch that out. And so what we did is basically decouple security and execution completely. So now relaying, which is now executing, it doesn't have any security piece to it, is totally permissionless. The user can do it themselves, the application can do it, a third-party executor can do it, and that really changes the liveness properties of the protocols a ton. And so, bunch of other stuff in there, but it's basically significantly more gas efficient, huge decoupling of security and execution, huge change on the security side of this forced Oracle and relayer to what we call DVNs now, where you can select any subset of DVNs. So there's already, I think, 25 live now, and you could say, I want 18 out of 25, and like these two must be included in every message pass. So you can just arbitrarily construct whatever set you want from any of the existing systems. And this can be things like you can use Chainlink, you can use Polyhedra ZK Lite client. You can basically stack and mix and match them however you want. And then this concept of DVN adapters allows you to use any existing validation structure. So like if you want to use layer 2 native bridges, fine, you can do it. If you wanted to use, say, Axelar's validation network, you can do that. You can use any existing structure within LayerZero, which is just super powerful.
That's really amazing. So I guess in a nutshell, LayerZero V2 decouples security from the actual execution of the delivery of the message, right? And would it be fair to say that the biggest feature of LayerZero V2 is the so-called DVNs, the Decentralized Verification Network, and the modularity that application developers have to basically configure their security stack here? The expressivity, I suppose. Would you say that's fair to say that that's the biggest upgrade that you shipped?
So I think most people take that away as the largest upgrade. Our only, like internally, all of that was possible in LayerZero V1. You could take an Oracle and basically make a meta Oracle. An Oracle is just a contract that says, hey, here's some party who's like attesting to state. That thing could say, here's 2 out of 3 parties. Here's, 75 out of 100 parties. Here's like, you can construct that smart contract however you want. So it was always possible, but people just didn't do it because it was hard. So it became more implicit, more native within the protocol. But it's not actually a completely new feature, but it's seeing new usage because it's so much easier now.
Yeah, that makes sense. And I think then maybe the most important aspect is this decoupling of the relayer, the executor now in LayerZero V2, and have that be an entity that completely specializes on the efficient delivery of transactions, I guess, in a very scalable way, and then have that be decoupled from the verification of the message, which in LayerZero V1 was somewhat intertwined, right? Like the relayer did some part of the verification as well, which arguably now that it's decoupled allows for, I guess, more specialization and sort of less problems from either of the two jobs that a relayer or a verifier has to perform. So I
was just gonna say, I think the way we think about the world is like, what properties do you want a transport layer? Like, what do you want your messaging channel to have for properties? And the things that we care about the most, excuse me, are immutability, censorship resistance, and permissionless. And so when you talk about censorship resistance, it's very hard to have that when you have a relayer that basically can go down. You can imagine a vote. Imagine we're moving the state where a very large governance vote, the relayer has incentive in the outcome. It's in the relayer's favor, and this last hour is happening, and the relayer just like has downtime, right? They could lose if other votes are going across, but there's just some technical difficulty and the votes sort of can't be counted over there, right? That there should never be a situation where that happens, ever. It should not be a vector of surface for any governance vote happening. You need to rely on this. And so what this decoupling does is effectively say, listen, as long as your security threshold is met, as long as you're 7 out of 10, whatever you've selected have basically attested and the state is there, the user can just go and say, hey, count my vote. Like I want it done now. The application can clear them all. Any third-party watchdog can clear them all, or the executor can come do it. So now it actually lives completely outside of the protocol. All execution is basically a value add service of gas abstraction of hey, as a user, I don't want to have gas asset A and gas asset B in my wallet at the same time. I don't want to have to wait for this finality to finish here and then go over there and self-claim on the other side. That's a messy process. Nobody wants that. So execution allows that to be seamless, but you still want to have this property of censorship resistance whenever you can. So through non-sorter enforcement, and then now permissionless execution, you have, effectively throughput is the throughput of the chain itself. So no constraints on overall throughput, and then no constraints on how execution can actually happen.
All right, cool. So just for the listeners to walk them through this, roughly speaking, and correct me if I'm wrong here, but roughly speaking, a user would initiate a cross-chain message, an LZ send on the source chain. At this point, basically the DVN that is specified for this pathway for this specific application picks up this initiation. They then do whatever verification the user wants them to do, like as per the configuration of the OAuth. And once that verification is done, any executor can come and fulfill this cross-chain message completion on the destination chain, right? And yeah, but that's basically the flow here, right?
Yep. So something happens, state is written to chain A. All the DVNs are effectively listening for the events being emitted and reading that state. So and then remember, they can look like anything. So this can be polyhedra ZK-like client is constructing a proof of all the signatures of every ETH validator, or it can just be like a simple attestation. It can be anything. They all create their attestations. They basically hash the packet itself, do their verification methodology, and then output that and sort of write that hash to the destination chain. When there's consensus on that hash in the endpoint, now anybody can execute it. So as soon as that security set defined by the application, which is here are the parties who can create an attestation, here are the number of blocks we want to wait from source chain. So like here's how much finality guarantees we need. All of that happens as soon as that threshold has been met on the destination chain. Now it's ready. And so the message technically on the LayerZero side is valid at that point. And it actually getting executed, delivered to the contract on the destination side, gas being paid, all of that. Now anybody can do that.
All right, cool. So the executor comes and executes the actual message delivery, but they have to operate within the constraints of the DVN configuration. And this could be anything, right? Like this could be a simple multi-sig. You need a bunch of signatures from the DVN to deliver the message, and thus verify the state from the source chain on the destination chain. And the attestation here could be anything as simple as just an off-chain signature that attests to that state, or it could be, like you mentioned, something composable, like a zero knowledge proof verification or whatnot. And even like when you say you could use chaining for this, for example, does this mean you would have to use Chainlink's protocol here? Would you be able to use the protocol as is, or would you need Chainlink to come online and also run a DVN for you in this model? So
Chainlink runs a Oracle in V1, right? So they've ran an Oracle from kind of the early days of LayerZero. So they do have this defined explicit action within the protocol, but then also through DVN adapters, you can wrap any external validation set. So if you say, listen, I think chain link CCIP is like the most secure, or wormhole is the most secure, whatever, right? Any accelerator, whatever you want, any external validation set, right? Which is really all they are. They're selling trust. It's a collection of nodes, and those nodes have some trust properties, and you want to include that in verifying your message. Within LayerZero, through this DVN adapter, you can just use that. So you can use Axelar's validator set right now and have that mixed in with all your other DVNs. Yep. So through DVN adapters, you can effectively mix and match any external validator set all into one thing, all implicitly within LayerZero. So you don't need to have, hey, this messaging protocol supports this channel, this one supports this channel, this one supports this pathway. I only want to use the layer 2 native bridges to go to layer 2s, but I want to use something else to come back, right? The beauty of LayerZero is one can do all of that within the same system, and you have unified semantics everywhere. You don't need to have 8 different interfaces you're dealing with, 8 different sets of code. If you have overlapping, you'll have similar security properties across all, while still being able to include like the strongest that you want.
Cool. So basically, I think the way you can think of LayerZero, the architecture here is, as an application, you can define and configure different security parameterizations based on which pathway, right? So for example, going from Ethereum to Arbitrum, you can use the canonical rollup bridge, which is extremely safe, right? For this sort of one-directional way, that works with LayerZero. But then going from Arbitrum to Solana, you can configure another verifier to verify the state for you on that pathway. And this way you can sort of mix and match very different verification mechanisms into a whole, right? That is then all of the connections that make up your application that might be deployed on multiple chains.
Yeah, and as a developer, you get, again, one single set of semantics for doing all of this, which is hugely important. Trying to write and deal with 8 different sets of code for 8 different interfaces to 8 different chains is a disaster waiting to happen, like for any app developer.
Yeah, that's great. Is there any contagion here, contagion risk outside of a one-directional message passing? I mean, it's a very complicated question, but for example, if your route is very secure between Ethereum and Arbitrum, but you have an unsecure route between Arbitrum and something else, or like even an unrelated network, like say between Solana and something else, and I think you shouldn't be affected, right? Because at least on Arbitrum and Ethereum, you still have this verification mechanism,
so
and not the other.
It totally depends on how the application defines it, right? So one of the most important principles within LayerZero is everybody else was designing sort of this hub and spoke model, which said if anything bad happens to this hub, any hack, any whatever, it can basically forge maximally malicious messages to every single network, even if totally accidental, smart contract bug, whatever. And every application built on top of that is equally harmed, right? So you can think the more applications you build around that, the more the need is for economic security at this hub in the middle, the more sort of risk there is in the smart contract layer, all of this. And so what you have is systemic risk. If something goes bad, systemic risk. One of the nice parts about LayerZero has always been, if you're using DVN set ABCD, and they are all malicious and colluding, and they are, corrupting your application, no other application is infected unless they're using ABCD, right? If they're using ABCF, totally fine. If they're using BCDE, totally fine. And so that is hugely different from any other system. So every application basically can protect themselves. If they run one of these components, as long as they're not colluding against themselves, they still have the fallback of the same security of everybody else. So they have at least that much security. So users don't need to, let's say, trust them as a single point of failure, but they have veto rights on every message. Nothing bad can ever happen if they're sort of actively participating in this. And so as an application, as you're designing this, it really depends on how you design it. If you design something that says, hey, you can go anywhere, mint any amount, and do all of this through any pathway, and this pathway over here gets corrupted, well then, yeah, maybe you can infinite mint there and then bring them back this way here and then come here, and it will look like an honest message, right? Because to your application on that chain, it is honest. Like, yeah, you brought in some supply. So this is actually why we invented pre-crime. What pre-crime does is effectively say, any application can define its own application-defined invariants. So for a bridge, the simple invariant is solvency. For some token, it might be, global supply doesn't exceed a certain amount, or is a certain amount, or it's equal to the amount locked in other contracts. And what happens is before any message is sent, every chain is forked locally. You run the state transition locally on that forked chain. You check the resulting state against a list of application-defined invariants. And only if that state transition does not break any of the invariants, then you deliver it on the destination chain. So you're effectively pre-simulating the transaction and then only delivering it if the transaction sort of is safe or meets those criteria. And so what this allows you to do is exactly what you're saying is, allow, if there was going to be some corruption on some foreign channel or some other chain path that you've set up, you basically can deal with that. One, the message will never get delivered, so it can't come back to this channel. But two, you have this sort of added layer of security. And if you look at things like Axie Ronin or any of the others, right? Like a simple system like this, like, oh, you're giving 650 million here and you got 0 on this side. Like clearly this transaction is not valid and shouldn't go. And you can only do this. You can only do this because in cross-chain, there is no atomicity, right? Like your best possible case is submit a transaction on source chain and then get it into the very next block on destination chain. And the delta, that little amount of latency between finalization on source and into the next block on destination, is enough to run the simulation. It's just not something we had in atomic surface before. So it's not like a surface that people worked on, but it's hugely powerful. And it's been running for every OFT and every Stargate since basically inception. And knock on wood, still no security issues ever. So
yeah, so that's really cool. The way I would think about this is that at the first layer, you can configure a lot of security parameters inside of your DVN configuration. You can work with different bridges, with different verifier networks, and then on top of that, and now obviously this should be your first line of defense, and on top of that, based on your application, you can consider adding more security layering in case of a hack or something. You could then have these invariant checks and whatnot. And given that LayerZero is asynchronous in nature, I think technically anything is possible here, right? I guess you could even make that part of the DVN verification process, right? Like sort of somehow, I don't know how, but yeah, okay, really cool. So then maybe to sum up the section on LayerZero V2, in your own words, what are the biggest wins of LayerZero V2 versus V1? And you don't have to go into the minutia of gas optimizations and everything, but what is the sort of one or two things people should take away in your own words?
Yeah, I mean, I think again, the things we care about are immutability, permissionless, and censorship resistant, and V2 just does it better than V1. It moves us closer to what we consider the end state. I think we launched V1 thinking we accomplished everything we wanted. We built Rails that fulfill those properties. Through 2 years of learnings, we realized there are some corner cases where it doesn't do those as well as we want. And right now, nobody else does those. So the bar was very low. We hold ourselves to a very high bar. And I think V2 just accomplishes that better. So yeah, I mean, biggest wins again, permissionless execution, decoupling of security and execution, all of this, I think play into it, but I think really everything is moved towards those 3 pillars.
Cool, nice. All right, so LayerZero V2 is live on Mainnet, is going to be live on Mainnet soon. Any dates?
No, it's live on Mainnet now.
Yeah, it's live on Mainnet, right? We participated in the launch there recently. And obviously, Gelato is also building a DVN for Gelato RaaS customers, first and foremost, but also looking to expand it to other chains so that more projects can use it in the future. But yeah, so what would you say? I mean, you just launched, so probably it's still all starry-eyed and everything, but projecting yourself now into the future of 1 or 2 years, what can you say about any areas of improvement still? Is there anything, is this the final version of LayerZero? I suppose not, right? But yeah, what do you already see could be improved?
The hope is yes. So we really, the way we designed it, again, is based around what we thought was lacking everywhere else. And I think if you look at where hacks have come from, everybody puts a lot of focus into validation layer, which is it should matter. But if you look at hacks historically, almost $5 billion of bridge hacks, 0 have come from validator set collusion. None. There isn't a single time we've had a malicious validator set collude to rug a set. Everything has been either social engineering in the case of Harmony and actually Ronin and a couple others, where they lost their keys, which you can say is just like a subset of centralization, and almost all through smart contracts, right? So upgradability, I think, is the largest surface of risk in bridging by far. I think if you look at the history of bridge hacks, right, like Poly Network, I believe, is a contract upgrade. Wormhole, $350 million hack through a contract upgrade. $1.8 billion critical bug shortly after, contract upgrade. $1.8 billion critical bug again, contract upgrade. Nomad hack was a contract upgrade. StockX recent hack, contract upgrade, right? And so the problem is nobody who's building on top of this, none of the applications can reason about the security properties of the underlying system because they keep changing, right? If you have the ability to change that system, like however good intention the developers are, however skilled they are, on a long enough time horizon, somebody's going to make a mistake. And it can be really dumb things like forgetting to initialize a contract call, which is a couple of these were literally just that. And it can be just having a bug in the code, wrong route. It can be so many different things. So you just see this over and over and over again. And so LayerZero, the goal was always 100% immutability. You have to give developers, especially when you're dealing with tens of billions of dollars, the ability to reason very concretely about the system that they're building on top of. And so what LayerZero does is the endpoint itself is like as minimal as it could possibly be. It basically just deals with nonce, so nonce ordering, which is the censorship resistance, and then these validation libraries. And the nice part is we've invented this construct of this append-only message library of validation libraries. What that means is you might have 3 validation libraries right now. This is validation methodology A, B, and C. And what you want is you don't have to deploy a protocol. And the reason everyone else is upgradability is they don't want to deploy a protocol and then like something new changes. They want to add a new feature. They just want to be able to upgrade and add it in. Of course, that's a nice developer experience. But what it is now is you have those 3. Those 3 libraries that exist are 100% immutable. They can never be changed. And most importantly, they can never be removed, right? So you can't take something away to only allow sort of malicious libraries or libraries that are heavily enforced with restrictions. Once they exist forever in perpetuity. We have the largest bug bounty in the world. It's $15 million for LayerZero, $10 million for Stargate. We spent $5.5 million on audits last year, which I think is the most in the entire industry. Those 3 have dealt with $50 billion of transactional volume, tremendous amount of usage, eyeballs on it, all of that, right? And so a new developer coming in, if you're a huge application, you can just be like, I want message library 3 that's been in production for 2 years, has secured this much, and that's basically how we weigh security, right? Like time in production and value secured should be like a reasonable metric. And what it allows us to do is say, hey, some new technology has come out. Something, Ethereum switches from Merkle trees to Verkle trees, whatever. Something happens where you have a more gas efficient library. You have something that's newer technology that should be more secure, new form of cryptography. It can be any kind of thing that is exciting. We can now add message library 4. That's entirely opt-in. It can exist. So we can continue to add new things to it. No protocol is forced to move. Nobody has to use that at all. And protocols who are on 3, 2, 1, they can wait 2 years until that's been in production and battle tested for a long time. And they say, okay, now I want to switch over to that. So I think the goal is that on the endpoint side, if we did it right, it will be the last LayerZero version that exists. It's the endpoint really is so minimal. It does almost nothing. And that's what you want. You want to be able to reason about the surface of security and want to strip that down to kind of minimal properties. And then everything else is handled through validation libraries.
Cool, nice. Knock on wood. So we have the LayerZero V2 base protocol, the endpoint, immutable, and that is so minimal that it doesn't have to change, and you can always trust it. And you push the upgradability and the patching and the additions to the periphery, I guess, to the DVNs, sort of to the user configuration of what their message verification mechanism should be. And that's opt-in upgrades by the users, right, or by the applications. And this way, the the applications can evolve with time, and they can use new technology and improve existing ones, adding more security as they grow and so on, right? Adding more verifiers or whatever they want to do. But the underlying base protocol mechanics never have to change for that. And that this way, at least we can have certainty there that there won't be any weird new bugs because of an upgrade at the base protocol level, I guess. So yeah. Is that a fair...
you give strong guarantees to applications. That's it, right? That's all any application should want. I'm not using the internet and worried like TCP/IP is just going to change. It's not going to change its interfaces. It's not going to change the way that it functions, right? So you have strong guarantees for every application to reason about what they want. If they want to move to a different form of technology, no problem, but it should never change on them without them actively doing something or having some say or knowledge or opt-in sort of discussion or decision around it, versus now where most other systems are monolithic parameterization. We're going to change something. Everybody accepts these changes, whether they want it or not.
Cool. Nice. Got it. So moving on to one area of improvement, maybe, which is getting ready for a world of tens of thousands of role apps and chains and so on, and which is obviously absolutely in line with the LayerZero vision and mission. But yeah, I know from working with you guys that currently there's still considerable cost to getting a new network endpoint live. This is because of, I guess, the mesh network. You have to connect it to every other endpoint and so on. So how do you think will you overcome this and reduce the barrier to entry for new chains, maybe even making it self-serviceable, which would be amazing for us. We have enough developers at Gelato who would love to just spin something up right themselves. Yeah, yep. How is that going to look like?
Yeah. I mean, I think there's a couple of ways. One, adding native messaging precompiles. So effectively a precompile for an endpoint would take away a huge amount of the burden. So I think when you talk about sort of RaaS or some of these others, it's easier to carve out sort of specific precompiles that propagate to all of them. So then you don't have to go and deploy a specific endpoint. You only have to do the wiring. The wiring can effectively be automated, right? So that's one thing. I mean, we've debated for a very long time whether or not permissionless endpoint deployment is something that should exist. Up until this point, we've opted against it because we think it's sort of like not having a DNS, right? You just have like all of these collisions. You have every application now. Like if you have 10 endpoints on a single chain, and each of them have been built. Like imagine a new VM. Imagine you want to go to Solana or some other, and there's 10 different endpoints built by 10 different teams. It's very hard for each team building your application to decide sort of which endpoint to use, how to reason about the security property. Very easy surface for people to like flip bugs into. Very hard to again compare this whole spectrum and the trade-offs. And then you basically have applications needing to figure out like, oh, if I want to talk to this application on this chain, it's this endpoint, and that application on this chain, on the same chain, it's a different endpoint. And so you end up having like a huge amount of redundant work. You have extremely messy, effectively namespace for how applications will communicate out. It's not like this chain ID anymore. It's like this chain ID is this endpoint there with these application sets. And so it really balloons the burden on the developer experience on how to reason about security within the system and security of the transport layer, on how to reason about like how to actually connect. Again, it's very easy. If you want to go to Arbitrum and talk to this application, it's just like, here's the chain ID, the chain ID for Arbitrum, and then you just have a contract you call on the other side. You don't need to do anything else. You don't need to think about anything else. And so that is, I would say, the largest, the best arguments against it right now. I think it makes the world in developer experience just extremely messy and extremely tricky. So right now we've chosen not to do permissionless endpoint deployment, but again, on precompiles where you have a set of code that is the same for all Tendermint chains or all X chains, whatever, and you have this precompile that lives there, then it can live natively on all of them. And then it's just an exercise of wiring it up, and it's not multiple endpoints per chain. It's one endpoint structure, and you just assign the chain ID and wire, and then it's fine. So I think that is likely in the world of 10,000 plus chains, you're going to see more and more native low-level precompiles.
All right, and just for me to grasp why currently establishing these new connections would be hard from the LayerZero perspective. Yeah, let's say, for example, obviously Gelato has rollup as a service, and in my mind, we could spin up new rollup as a service chains that, you know, might be very early stage, not yet interesting for you guys to serve for whatever reason. And we just spin them up. We deploy LayerZero, maybe even as per a standard that you prescribe, and maybe even at a specific address or something. And then we also, like the way I think about it, and I might be wrong here, is we would just have to provide the DVN also on the other networks that this network wants to connect to. So our DVN has to be deployed everywhere where this network wants to connect to have these pathways. And then, yeah, there would just, the user or the application would have to be happy with the DVN, right? But let's say that is the case. We would then just need to have executors that fulfill this verified message passing. Why is this not so easy to do in a permissionless way? Like, is there some registry that is kept on chain for all of these endpoints that you administer, or is it more stateless than that?
Yeah. So I mean, every chain needs to know a chain ID to wire up to it, right? So every chain that is wiring up to that chain, so every pathway that's being enabled, if you want to mesh, they all need to effectively send a message and now be wired to that destination. So in order for that endpoint to be able to communicate out to Ethereum and Ethereum to it, they need to basically have a handshake early on, because otherwise, again, it's very easy to have surfaces of malicious action. It's hard for developers to reason over the security of the entire system. And so that part is like, there is a handshake, but the handshake it's not that hard. It's not the end of the world. I think the larger part and the bigger issue is really the execution side. And so like our executor that we run does 50 to 80 billion RPC calls per month. There's a period of time where we're doing more than 50% of all transactions submitted to Arbitrum and Optimism. We're like 6 out of the top 10 gas consuming applications, hundreds, tens of millions, 100 million plus messages being written to chain. What that has done to a bunch of other chains is like we've broken 18-hour backlogs in L2s, Phantom, Avalanche, a bunch of these chains like broke under overall volume. When you talk about running it, it's a very non-trivial setup to run. If there are other people running, plus you're having tens of millions of gas assets that you're outlaying, right? So you got about $30 to $40 million in gas assets. It's quoting n squared pathways in real time. So you have to give gas for like, here is the price of X in units of A. Here's the price of X in units of B for every possible way. And the quote is real time enough such that if you're quoting negative spread, then somebody is just going to fire messages across that pathway and profit. They'll just be getting free gas on the other side. So it's something that has to have like very high degrees of sort of like reliability of quoting. Otherwise, you open yourself up to this huge vector. So all of that to say, running execution is very hard. If there are other groups who are like running their own executors, if you guys are like, we're going to run an executor and do this, I think that would make it a lot easier. The hard part is a lot of these chains that are underdeveloped, so newer chains, typically have like very not great RPCs for the most part. You'll have like a single public RPC. Maybe you'll have a couple of private RPCs. No sort of institutional RPC providers are there. And what you see is just, again, under any sort of reasonable usage, just like crumbles. And then you have this really terrible experience where every user's like, hey, my messages are stuck forever. There's this huge backlog, and it's like, okay, the chain can't ingest it, or all the RPCs are dead, or all of these things that go into it. So usually it really has just been an exercise in that. It's like wanting to have clear developer and consumer experience across everything. It's the exercise is the same for any of these deployments. Is deploy an endpoint, get a node up, and then basically just be able to do the handshakes or wire up everything, and then you're live and running. There is a world if you are doing the execution and you're doing the DVN side, that it would be more possible and easier to deploy at scale. But again, I think a precompile especially for RaaS stuff would solve a huge amount of this. Yeah.
So I mean, apart from all of the complexity that comes with actually running LayerZero in production, which is a big part is the execution, the executor role, which I believe in our RaaS context is becoming less and less of an issue, because a big problem of the executor is how to make it profitable as well, or how not to burn too much money, right, on it. And that is becoming less of an issue on our rollup as a service rollups, because many of them will basically have zero gas cost if they use a DAC or whatnot, right? So I guess the less operational cost you have as an executor, the less of a problem you have. You still need scalability and everything. But
if you're going to Ethereum, you still you have to quote the user. So you're on chain A that has zero gas cost, but you want to go to Ethereum and your Ethereum gas is going to be $15, right? You have to collect $15 of sort. So you have to quote out, here is the price of ETH in units of X. I'm going to take all of the X here, and then I'm going to pay the ETH on your behalf on the other side. So the user doesn't think about the gas on the two sides. So the user just pays everything up front, and then the whole transaction flow is executed. And so you have to be able to quote X to ETH, and then be able to collect X and give out ETH, and then not be getting just completely destroyed on that quoting process. But you will definitely, between chains that are effectively free, you'll still need to have gas to actually execute for the user on the other side, or maybe not. But when you go out to any other chain that does have high gas costs or even moderate gas costs, you'll need to consider how that happens.
Yeah, definitely. I will definitely dig in after this recording to find out maybe ways we can help make that easier to ship. So a couple more questions. How much time do you have left, if I may ask? Is it 5 minutes or?
We're like 5-10 minutes, I think should be fine. We can go to 10, no problem.
Based on that, I would prioritize the questions I still have left. So yeah, I mean, just to final question on the previous topic about adding new networks to LayerZero. First of all, the handshake, does this basically mean to add a new endpoint? Really what happens is you guys have to figure out, is the person registering the endpoint legit, it's almost like a KYB process or something, right? Like, are they actually the owners or commissioners of this chain, right? Is this going to be the canonical LayerZero endpoint is ultimately the question here, right? And also, has the endpoint being correctly deployed, right? I guess this is where the complexity comes from with outsourcing this. You don't want to add endpoints from scammers or that have been not properly deployed, I suppose.
Yeah, so again, right now, everything, so the only thing that LayerZero is fully responsible for in the network, or LayerZero Labs has full responsibility for, is endpoint deployment and setting the defaults. That's the only ability that LayerZero Labs has at all. Outside of that, all of the chains that are existing right now, all the messaging libraries, everything that exists within there will exist in perpetuity until Ethereum and other chains make breaking changes, or until the end of time, right? So just forever. Anybody can use them. You don't need to ever think about LayerZero Labs. You can run every component yourself, entirely permissionless. New chains, endpoint deployment is LayerZero Labs, and setting the defaults is LayerZero Labs. So right now, every new endpoint deployment comes from us, deploy, wire up, etc. What that gives is one construct for every person to think about. They know who's deployed the endpoint. They know the endpoint has not been tampered with, or anything like that. So again, very easy for a developer to reason about the security of the overall LayerZero network or LayerZero enabled chains. So that is the current structure. So there's actually never been an external endpoint deployment currently.
All right, cool. Yeah, I'll definitely have to double click on this in my own time later on, because I definitely want to see how we could make that possible to have it be more permissionless. All right, cool. Yeah, so I mean, I've seen that you sort of describe LayerZero V2 or maybe even before as the TCP/IP and of Web3. And I wanted to ask you, do you think in order for this to reach its max utility and to really be useful in its entirety, it has to become the single ubiquitous standard across every chain in 5 to 10 years or so? Or do you think there's also a possible version of the future where maybe it's not a single standard to rule them all, but you can also sort of interoperate with other networks, more like a sort of network of networks approach? Or do you think you are already this sort of network of networks approach to tie everything together with DVNs and so on?
I think so. The way we think about the world is the way we think about the world is largely all we want to build is the lowest level primitive of the highest possible utility. That is the framework that we use for everything. So when we think about the world, there's a reason we're not trying to solve the validator. So most other protocols who are trying to do messaging, they're like, here is a validator set. Here's why it's special. It's our 19 nodes. It's our staked group. It's, whatever. They're trying to solve a trust problem, and the transport layer is secondary. For us, we're trying to solve the transport layer. You can use any of those systems, those trust systems within LayerZero, but the transport layer is the thing that we are trying to solve. And validation is this separate problem that we think will evolve over time. We think nothing that exists now is going to be de facto sort of 5 or 10 years out. Like, that's an evolving space and is going to be heavily commoditized down, in our opinion. So transport layer is a problem we're trying to solve. I think if you look at any technology, there's just like, there are very few cases where you converge on like a bunch of different standards. It's just so hard to reason about. It's so hard to build abstractions above and for developers to actually have good experiences, and feature parity diverges, and it's very messy. I'm a very, very strong believer that will be a single methodology that encompasses 99% or 95% plus, maybe 99% plus of all messaging. I just think they're again, if you look at any existing technology set, it just makes zero sense, and there's zero benefit to the developer, which is ultimately the consumer of the technology, to have a world like that.
Yeah, makes sense. So we are basically saying LayerZero is a bet that this will become the omnipresent, the ubiquitous standard for Web3 interop between any Web3 blockchain, really. And that is the future that we want, because then we have one standard to align on, and we can all reason about the applications that are built on top of it, and sort of the interop security mechanisms that underpin it. All right, cool. So what about this sort of current debate about asynchronous communication versus synchronous communication, and things like based rollups, based sequencing, OP superchain, Polygon's egg layer, sort of all these interop projects and sort of proposed mechanisms. I don't think they really exist today yet, shared sequencing and so on. Do you think, I mean, first of all, I already know that there's always going to be a world for both, right? You will always need asynchronous and synchronous communication of sorts. But do you think, how big of a play will shared sequencing have, and synchronous communication? Do you think it's going to be it's a bit overblown, and will be dwarfed by async communication? How do you think about this? How useful is async alone, or do you think synchronous composability between many chains is really a big missing piece that we desperately need as well?
Yeah, I mean, you don't even get like true synchronous communication. My biggest problem with it is the more synchronous you want to make things in a system like that, the more centralizing of forces you need to have. Because if you want things to be atomic, then you need to basically tie them together and say, if any leg of this transaction fails, then every leg fails, right? So you can imagine a transaction that touches a bunch of state across a bunch of different chains, and you as a solver are effectively trying to solve for how to piece these components together to make sure that they're serialized in a structure where, like, the state is what you expect it to be at the sort of transaction. And then you have one piece of that state fail, and you need to unwind the entire transaction, which then affects everything else that was like structured around this across every single chain that you're trying to synchronize. You're just not going to be able to do that in any sort of node that can be like broadly distributed and decentralized. Is just too complex. And so you're moving to like a very, 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 very small number of solvers who are effectively doing all of this. And I think there are risks to that. But again, the space is sort of making that trade-off more and more of, we'll have some sort of off-chain structure that is heavily centralized and does this, and it will sort of propose that. And as long as we make it a reasonable marketplace, then that will be good outcomes. And you're just like synchronous communication within a small subset, but async out also doesn't really make sense. Like it does in a world, again, it's a great dream, because in the world where it succeeds, all of the volume happens here within our set. And this was sort of like the hub and spoke model always, was just like, everything, the network effects will be so strong that everything will live here. So like this thing will have so much value. So like you need to ask yourself, do you believe that the subset of things that are connecting are going to be so powerful that it just sucks everything in and everything lives there? Because the alternative is you as a developer need an application that has like synchronous communication here and async communication there. And like async design patterns are just completely different than like atomic or synchronous design patterns, just completely different. It's not even close. And so like designing a lending protocol who has like, okay, now I have to design effectively two completely different protocols, one for async and one for synchronous, is such a high burden on the end developer. And for what? To have some level of guarantee when I'm going between these two very specific networks that I like know something will be there, versus designing an asynchronous where I don't need to care if it's definitely going to, or know ahead of time because there's been like pre-allocation. So I mean, like, if we could do everything synchronously, it would be great, but it is impossible between sort of all networks. So you're going to live with async. What does that look like overall? So I don't know. It's a very interesting design space. I think it has a bunch of its own trade-offs. I don't think the trade-offs are discussed as often or as honestly as they should be right now. But it's interesting for sure, and I think there's a lot of eyes on it universally.
Yeah. And I think it ultimately boils down to liquidity fragmentation as being this sort of arguably the only problem that is described in this asynchronous environment. And I think it depends on what liquidity fragmentation you talk about. But I think there's even there at the application level, right? There is design space to, at least for the bridging aspect, to make liquidity fragmentation less of an issue with a mint and burn design. I'm not saying that anyone is advocating for it here or not, but this is a possible solution, or just to have quicker, quicker settlement times with ZK rollups, for example, and so on, so that you can more quickly rebalance your inventory as a liquidity provider like Stargate. So I think, yeah.
I was just gonna say, yeah, the problem lives somewhere. The developer can just decide where it wants to live, right? It's very easy to make. If you want to go to layer twos and say, here's, make an OFT, so there's seamless liquidity between layer twos, that's totally fine. The problem that you're going to run into is effectively, well, I guess if Ethereum is your only settlement layer, you won't run into a problem. Everything can just roll out and you can just have a completely seamless liquidity between that layer and everything comes out to Ethereum. If you want to be able to lock assets from other chains and inbound them to the L2s, then you just have an inventory problem. Like I've moved X million from here and X million from here, and now like the user wants 1.5x million out here, right? But there's only like X million there, not 1.5x. It's split between the two. So you could have an inventory problem on withdrawal, which just means, hey, user, you might need to take assets on a chain you didn't necessarily intend to or want to. But that's like sort of like the very tail case where you've run out of inventory and have no way to balance inventory between them. Or you can push it here and you can say this asset on Arbitrum is totally different than this asset on Optimism, and we're going to have pools of them and you need to like swap them. And once you've run out of inventory within the system, then it's basically dead. And so, ultimately those are like the only two subsets of the problem. Is just there's discrete inventory here, and you have to deal with inventory issues there when you've run out of one, and that's like the channels come up and then the inventory lives here, or inventory comes up and everything lives here, and you abstract away that and you say, I'm willing to treat these all as canonical and equal, and now I can have seamless liquidity within, and then everybody just withdraws out to the same pool. So it's an addressable issue, but it's a design pattern. And the question is like, what does it, right? You're inheriting different sort of risk properties. Do you treat all L2s as equally the same, or all the native bridges exactly the same trust assumptions? If so, then it's very fine to say, liquidity lives here, move it up. Now we just move seamlessly between, because it doesn't matter. But if one of them was wrong and you have this corrupted channel, now everybody's sort of like socializing that. If you don't want that, you say, lock them up in very discrete pathways, have them be discrete inventory here, and then you just deal with the inventory issues on the chains themselves. And so I think it's not that complex, in my opinion. It's very solvable. The question is, what is the trade-off? And there are always trade-offs. What is the trade-offs that developers want to make? And it is just assuming assuming commoditized or homogeneous risk, or not.
Yeah. Yeah, I think ultimately also now that we see more and more application sort of centric development again with rollup as a service and roll apps, I think ultimately it's just going to be a game as well of competing for liquidity, right? And maybe you can, as a upstart project, join a chain that has some liquidity pools that you can tap into, but once you're big enough with your brand and everything, you can just compete for liquidity to be on your app chain, right? You want to be one of the top 10 DEXs, DEX chains, perp DEX chains, whatever. And this dynamics is still there. And ultimately, this is, I think, how the web developed as well. And competing over liquidity is fine, right? And then on these top DEXs, you will have enough liquidity again, and fragmentation will be less of an issue. So yeah, I think you lose some aspects that people saw early on with Ethereum and Solana today and so on, which is this sort of global pool of liquidity. But you still have so many other of the blockchain benefits there. And yeah, you just need to attract enough liquidity, and then you have synchronicity within your own boundaries at least still. So I think this is how it's going to pan out. So thanks a lot, Bryan, for coming on. It was a nice conversation. I learned a lot about LayerZero V2, and I think people know where to follow you. You're the Pudgy Penguin guy on Twitter, Primo something, so I don't think we have to do the usual podcasting here. Enjoyed it very much, and I hope to see you for a second episode where maybe we can dig deeper into liquidity management and so on from the Stargate point of view. Yeah, thanks a lot, Bryan.
Sounds great. All right, thanks so much.